Hello everyone, welcome to the NN Classroom. Today, I'd like to share with you a past paper question from 2018 Time Zone 0. So question number 3, again, mole calculation question. Let's see, given an andesite tablet, so which is something that can tackle with our stomach acid of hydrochloric acid, but this time it's not asking for the chemical nature behind this andesite, right? So an andesite tablet contains 0.5 grams of the sodium hydrogen carbonate. Given the molar mass of this whole thing, 84, is now dissolved in water to give a volume of 250 centimeter cube. And so asking what is the concentration in mole per dm cube expressed of, very important, the hydrogen carbonate ions in this solution. So do remember, now we are finding the concentration of hydrogen carbonate ions. So that means the major actor for this question is not the whole thing of sodium hydrogen carbonate, but only the hydrogen carbonate ions inside. But the thing is, we know that within one of the units of NaHCO3, we still be equivalent to one of the units of HCO3 minus. Why? Because within the formula, we see the hydrogen carbonate ions of the ratio also 1:1 mole ratio between sodium ion and the hydrogen carbonate ions. So that's why within 1 mole of this entire unit, still we have 1 mole of the hydrogen carbonate ions. So that's why this question is not super tricky, because the hydrogen carbonate ions within the whole thing is still 1:1 in a ratio. But then you can imagine the question can be now increased in terms of the difficulty by changing the subject from from sodium hydrogen carbonate maybe to something else like calcium hydrogen carbonate. So in this case, the mole ratio will be different. So be super careful about what are the concentrations that we are finding at the end, right? So for this case, normally we do with the normal approach, because now we ensure that the target and what we are going to find out from the moles of hydrogen carbonate with sodium is still with the same ratio, 1:1, right? So that's why what do we do? First of all, we have the mass over molar mass, right? And this will give me the moles of the sodium hydrogen carbonate, because now given to be 0.5 grams and the molar mass to be 84. So simply we can plug in, and that will be giving rise to the number of moles of the NaHCO3, because the data that we plug in is referring to sodium hydrogen carbonate. But we know that given the sodium hydrogen carbonate is exactly like what we're talking about, the hydrogen carbonate ions. So that's why this will be equivalent to the number of moles of the HCO3 minus. Makes sense, right? Only because this time we're having a ratio to be 1:1, right? So right now, after we have the moles, what are we finding? We are now planning to dissolve this bunch of mass into making a solution with the volume of 250. So that's why we should using the second equation, which is the concentration times the volume. So that's why finally this is the relationship. The relationship will be the mass over the molar mass, which refers to the moles. This time all the moles will go to the solution, and the solution will be making up with the volume of 250. Make sense? So finally we plug into the information from the given question. So the mass will be 0.5 and over the molar mass given to be 84. So it equals the moles, but in this case we no need to work this out, because the given choices are not with any numbers but just expression. And so this will be referring to the moles of the hydrogen carbonate ions we confirm because of 1:1 ratio. That goes to the concentration that we are going to find out times the volume. So this time we are having 250, but remember cm cube, we need to change to decimeter cube. So what do we do? Divided by 1000. So once you divide it by 1000, it becomes 0.25. Make sense? So finally make concentration as the subject. So this 0.25 goes to the left hand side, which becomes the denominator. So 84 times 0.25. So that's why obviously matching with our choice B.